All right, so we'll get into some of the theory here on authentication. And so we're going to be making a login system, and we'll be working with permissions. And so if you maybe are a member of a group, also known a role, you have a certain role as a user. Maybe you're a customer, maybe you're an administrator. Roles are basically your groups. If you have permission to either get to a resource or you don't. So oftentimes when you talk about authentication, you also talk about authorization, and those are two different things, as we'll get into. So we will be doing both of those things, both the authentication and the authorization, in this class. And so this lecture outline, works along with our labs, just as they have in the past, right? So we'll go through a little bit of the theory, and then quickly we'll transition it into actually writing code. And so this is available on Inside Rankin. As you kind of scroll down, you get the authentication lecture outline. And so, kind of highlighting what is authentication, the process of determining whether someone or something is who they say they are. So driver's license, authenticates you as a person, as a valid form of ID, right? So typically on websites, when you authenticate is to say that you're providing typically a username and password, although there are many other ways to authenticate, not just, username and passwords. And so we're very familiar with usernames and passwords. Typically when you pay with credit card, you provide your PIN code and you're authenticating who you are. You're signing, a receipt, your CVC code on the back, so on and so forth. You authenticate with your phones, right? So every time you log in, you've got face authentication, you've got your PINs, that you can provide. You authenticate when you log into your computer. When I went to work today, I had to scan, I had to authenticate to get into the building, right? So I am an employee, therefore, let me in. All sorts of keypads and biometric locks, right? Fingerprint, handprint, eye and voice, magnetic cards, RFID. These are all forms of authentication. So we're again going to be focused on the simple one, which is username and password, and that's what we're going to create. And so this dials in a little bit more the different factors, something like your password, your possession, something you have like your ID badge, your inheritance, something that you are, your thumbprint, that is those are the main kind of forms of authentication typically. And again, they get into your knowledge of your username and password, your knowledge of your PIN, inheritance, again, what you are, right? Your fingerprint and your facial recognition. Again, we're going to focus on one-factor authentications, although modern apps, more so and more so are having two-factor authentications. So, I use my Google Authenticator in just about every website nowadays, because username and password, if you know anything about security, nothing is secure, on the internet or your credit cards. How many data breaches have there been? So oftentimes providing username and password isn't enough. They want something like, hey, we're gonna text your phone another temporary number for you to authenticate. So not only do you have to have your username and password, but you have to have a physical device on you. And so there's all sorts of two factors that are out there. Turns out that when it comes to making usernames and passwords, we pretty well know how to do well. I guess the first thing to say, and you may or may not realize it if you stop and think, is like, hey, you need to just save it to a database. Well, we already know how to do that. We know how to take a username property and a password property and save it in plain text. Of course, you don't want your passwords saved in plain text. When I look at any database, and if it stores credential information, you should not store that in plain text. Therefore, any database personnel working with the database could just read someone's password. So we do know how to do a portion of this. In fact, we know how to do most of this, and that's just saving information to a database. But what we don't know how to do is take that password and basically encrypt it so that an end user, be it a database admin, I shouldn't say an end user, an administrator, even an administrator can't access your password. And so there is a package for that. When it comes to hashing, again, hashing is just taking something known to an unknown value, and basically encrypting it, if you will. And so you can run a simple function to create your own hash, okay? And so these examples here are just their own little functions, their own little JavaScript functions that can take an input number and return some random output number, right? So input something known, output something unknown. And so, it's important to understand what a hash is, right? A hash will encrypt data. In other words, it would secure it. And so that an intermediary, someone trying to intercept that data, is unable to. And so when it comes to like, hey, you can write your own hashing algorithms, well, it turns out there's a lot of value in hashing. And so MD5 hashes is a common algorithm to, again, take a known value and encrypt it into something unknown. And of course, then in that algorithm, you have to be able to unencrypt it, right? So it's a two-way street, right? You got to encrypt the data, and then you have to unencrypt the data, and basically get it from that hashed value back into its regular form. And so MD5, and then SHA-1 and SHA-2, which is also referred to as SHA-256. And these are just basically different built-in hashing algorithms that are commonly used, that are hard to crack. They're not impossible to crack, but they're very, very hard to crack. And it says SHA-2 is the only one on this list that is secure enough for passwords. And so, even though these are different hashing algorithms, you want to use SHA-2. MD5 has been considered insecure since 2008, and then SHA-1 has been considered insecure since 2010. So yeah, SHA-256 is kind of the gold standard. The tool that we're going to use, the library, is called bcrypt, okay? And so bcrypt's really straightforward. Like at the surface level, we're going to install bcrypt, and then we're going to use it to hash our passwords. And so when we store our passwords, we're not going to store them in plain text. We're going to store them basically in an encrypted state. So we're not going to know the end user's passwords. We'll use bcrypt to both hash or encrypt and decrypt the passwords when they go to log in. So when they register, we'll hash. And you can kind of see here like a function that uses bcrypt. It's a real simple method, right? It's an asynchronous method, so we have to await it. And you just say bcrypt.hash, the plain text password. Okay, so whatever the password is the user gives you, and you pass it through a number of salt rounds. And let me describe what salt rounds are with a video. So let me find a video quickly to bring in here. Okay, because I think recording a YouTube video on a YouTube video could get it flagged, could get my YouTube video flagged as unauthentic. And so I'm not going to play this here, but what I am going to do is I'm going to save this to the summer playlist, and I'll link to it in the Discord. And here's the URL if you want to manually type it. But the point is, this will describe this process of salting and how it is an improvement over just your hashed passwords. And so we'll take a short 11-minute thing here and watch this video. Okay, so hopefully you got a chance to watch that video, which not only was a good explanation of what a salt is, but also a little bit of a promo for bcrypt and being able to effectively, again, nothing is completely secure, but what you can do ultimately is slow the hackers down so that it would be impractical for them to just from the amount of time it would take to actually, get your username and password using a tool like bcrypt would just be impractical for them to do. And so, again, kind of looking at on the surface, we're going to bring in bcrypt. We're going to run a hashing algorithm and provide a number of salt rounds. And so this would be like your clear text password, unhashed, and then how many salt rounds to put them through. And then that's, saving. This is going to be what we do when we save the user's password to the database, and so it'll be an encrypted password plus some number of salt rounds to really secure it. And then on the other side, right? So this is going to be the encrypting the data, and then you have to decrypt the data. And so this the hash bcrypt.hash is to encrypt, and bcrypt compare is the plain text password. Again, the user's trying to log in now. So what password are they giving me to log in with? And then what is the hash value that is stored in the database? And this compare will basically return true or false, and saying, hey, the password that is given matches the hash with the data that's saved in the database. And so this is a way of completely, removing our ability as programmers to see the password or know the password. And same thing kind of on the hacker side. And so again, big picture, bcrypt is one of the tools that we're going to use to encrypt and decrypt our passwords and save that information in the database. Then we get into cookies. When you authenticate with a website, depending on the website, some people think about this, some people don't. But, for example, the bank, if you closed your browser, more than likely, you terminate your session with the bank and you're going to have to re-authenticate. And so it's also a timed session. So you might be 5 minutes or 10 minutes of inactivity. If you don't move the mouse on your banking website, they're going to log you out, right? So the bank is an example of, hey, we got lots of sensitive information, people's money in here. So the authentication duration doesn't last very long, right? They're going to time you out. If you close the browser, you're going to have to re-put in your username and password. However, on the other end of the spectrum, right? So you got banks on one end. On the other end of the spectrum, you have social media and social media apps. And so, on your phone in particular, think of Instagram. It never logs you out, right? You're always logged in. They want you to interact with their app. They want you to scroll infinitely, to make basically money, right? That's how Instagram makes money, is with advertisers and getting lots of usage out of their apps so that they can sell advertising. Facebook's the same, TikTok's the same. The more you scroll, so on and so forth. But the point is that social media apps never log you out. Okay, the way that they keep you logged in is they do re-authenticate you through, storing your credentials, in, especially on websites, they're stored in cookies. Cookies are little text files with information. And so you can store username and password in cookies, and these cookies exist on your device, on your computer, on your cell phone. And so every browser has its own set of cookies. That's something that a lot of people, a lot of kids are going to learn. I was looking at this rated R movie, and I don't want my parents to know that I was looking at this rated R movie because I'm a 12-year-old kid, and they learn to clear the cookies, right? And so, from little kids, we learned that, clear your history, clear your cookies. And so when you're clearing your cookies, you're essentially, getting rid of all these little text files that are on a per browser basis. So, I just want to point it out that, Chrome has a different set of cookies than Edge has a different set of cookies, than Firefox. They all have their own, each browser has their own files on the hard drive in different folders and different locations that can be used for authentication. Okay, so again, definition of cookies: they are small text files stored on the client. They are often used to remember things like your username, email address, session ID, session token. That's kind of something we're going to get into. What is a token? Session token. Language, time zones. Again, they store information about you, and so when you browse, especially when you get these third-party cookies, right? You go to BurgerKing.com, right? And BurgerKing.com, essentially works with, for example, Facebook, right? And all of a sudden you go to Facebook and, Burger King sold their cookies, sold their information, the information that Burger King collected about you to Facebook so that Facebook can use that to advertise Burger King. And so all the time, cookies enable a very lucrative marketing business on the internet. I mean, that's how a lot of money is made on the internet, about collecting information about you and then selling that off. And there's a whole fight back about, my privacy, my data, and not collecting information about me unless I agree to it. So you've probably noticed on a lot of websites you go to nowadays, it's law in the EU, if there's a website hosted in the EU, they have to have a cookie policy and you have to agree to it. So a lot of websites nowadays have cookie policies you go to, and they're saying, here's how we're collecting your information and using it. And you at least have to click a button by law in the EU to agree to a cookie policy. So, most people don't read those unless you're a lawyer or something, but most people, at least they're making you agree to it. But there's, hundreds of millions, if not billions and billions of dollars in this business, big business of collecting information and about you and then selling it. And you'll often hear people say things like, I'm convinced that my cell phone listens to me and records me when I don't know about it. And that's how, I was on this app and all of a sudden they're marketing for this other thing. And it's because my cell phone listens to me. And it's tracking your habits. It's tracking where you're going, and it's recording that. And then those sites are selling information to other sites. And, And then they're advertising against you because they know what you're looking for. They know what's on your mind, so to speak. Okay. Now, even though a cookie is ultimately stored on the client, that information can be sent to the backend code. So that's something to keep in mind. Even though the information is stored on the client, we can use that on the server. Like, we can read that on the server. So again, if we're requiring users to authenticate and a user has an authentication token saved on the client, we can accept that authentication token as the user being logged in. Okay? And so, again, that's how websites remember you. That's when you click that box to remember me. They're ultimately saving a cookie, and a part of that cookie has what's called an authentication token. And that authentication token provides the credentials, of your username and password to get you in. Okay? And so it's ultimately with these cookies that you can stay logged into a website. Okay? And it depends on the website and the security needs of that website, how long that authentication token is considered valid. Is it 10 minutes like a bank, or is it infinite like a social media site? It depends on the security needs of the site. So the last piece here, cookies should not be considered secure because users can freely modify or delete them. So a cookie by itself, if you know what you're doing, it's stored on the front end. So anything that's stored on the front end, can be manipulated by, and that's basically freely modify or delete them by people who understand code, And so I can modify my cookies, I can delete my cookies. So you can't consider them secure. That's the reason why we have tokens. Okay, tokens are stored in cookies, and tokens are something that you can encrypt information with. And so cookies by themselves are not secure, but when you add a token, you can get some hashing and some encryption going on, and that's considered more secure. Okay, so in node land, okay, so on the server side code that we're writing, we can create a cookie on the client as simple as this. So here's our response object, right? Remember, request, response, and next. So we send a response object. We do res.cookie, right? So this is going to create a client-side cookie. We're going to call it theme, and it has a value of dark, right? So our cookie just has a name and a value. So it's a real simple way to create some information stored on the client. And this is our expiration. Now you say, well, what is 1,000 times 60 times 60? Well, 1,000, this is basically like this. So 1,000 is 1,000 milliseconds in a second, right? So this 1,000 is 1,000 milliseconds, right? That represents 1 second. There's 60 seconds in a minute. So this is 1,000 seconds times 60. Well, that's 1 minute, right? So 1,000 times 60 is 1 minute. Times 60 is 60 minutes. So this particular cookie lasts for 1 hour is basically what that does. And so this cookie called theme that has a value of dark would exist on the client as a valid cookie for 1 hour. And really, we would just plug in the number there of whatever. Okay, so that's how you create a cookie. And ultimately, what are we doing here? We're going to create a cookie to store authentication credentials. This is kind of the step one of the two-step process. okay, is to create a cookie, and then to read a cookie is, again, that data is coming from the request object, so that's coming back from the client. It's rec.cookies.theme. Okay, and then you would store that data here in this variable called theme. So point is, create a cookie, read a cookie. Just like bcrypt, you have to install a dependency. And in order to do this code right here, there's another dependency, and that's called cookie parser. Okay, so we'll install cookie parser, we'll bring it in, and we'll install it as middleware. Okay, and so this cookie parser is the second dependency that we'll install today, and that will allow us through Express to create client-side cookies. We're creating client-side cookies to store authentication credentials in and basically keep a user logged in or whatever we need to do, but basically that's how we're going to use it. We're going to keep a user logged in for 15 minutes or an hour or 3 days or a million days or whatever it may be. Right, so dependency number 1 is bcrypt to encrypt passwords. Dependency number 2 is cookie parser, and cookie parser is going to be used to create client-side cookies to store some credential information. And there is a Chrome plugin called Edit This Cookie that you can kind of install, add to Chrome. This is the first and most popular cookie editor in Google Chrome. So, you know, by default, you got to go into here and you got to go into settings and you got to kind of dig through settings to look at your cookies. But I'm going to go ahead and add this to Chrome. And let me go to here, and I'm going to pin this so I can see cookie parser. I'm going to hide Ad Blocker Plus and Chrome Remote Desktop, uBlock. I don't need to see. I'll keep that. Okay. So go ahead and install that, and that'll kind of allow you to easily look at your cookies on the client side, right? So easy enough. Okay, and so when we're saving data, there's a lot of ways that you can save what's known as a session, right? So a session is just an open connection between the client and the server. Okay, and so when you have an open connection between the client and the server, you know, the first thing to remember, HTTP is considered stateless. So the client, you know, makes a request to the server responds to that request, and then they forget about each other. And so out of the box, HTTP, you know, there's no sort of connection that stays open between the client and the server by default. And so if you want to kind of keep an open connection between the client and the server, you have to create a session. And there's different ways to create sessions. One of which we've kind of already talked about is storing a cookie on the client. Right, and it says, however, to facilitate authentication, which is what we're going to do, shopping carts, right? You leave Amazon, you come back, you still have the same shopping cart, right? It remembers some information about you, right? It's persisting data about you. We need to store data over a long period of time. So how are we persisting data? Again, by default, HTTP doesn't remember anything about you. One option is cookies. Stored on the client. It's, you know, as we've kind of seen with this, you know, edit this cookie, right? It is editable, which is funny. We're talking about cookies and almost edible. Anyways, whatever. Editable by the user. Accessible by front end and back end code. Sent to the server with every request until it expires or is deleted. And so, every time the client and the server are interacting, the cookies are sent back and forth, right? So you kind of get the little sad face because that's extra networking traffic, even if it's not necessary. Okay, so basically cookies by themselves are not secure, and they're transmitted back and forth every time, which also creates extra networking traffic. You can store information. So this is obviously a client-side solution. You could store it in the server's RAM, which is not something we're going to do, and it has its own set of crashes. We could store it on the server side in a database. So you could store session information in a database. Not going to do that either, right? Instead, what we're going to use to store session information is called JSON Web Tokens, or JWT. So again, inside of our cookie, we're going to have a token. That token is going to store our session, which is, again, kind of making the server remember the client is what a session is going to do. It's going to make the server remember the client, because by default, HTTP doesn't do that. So a JSON Web Token, again, it's using cryptography, right? So there's going to be encryption going on here with private key and public key tokens, right? So in encryption, there's this encrypting and decrypting mechanism with what are referred to as keys. And so, basically that SHA-256 that we were talking about is what this is going to use to secure our tokens. So encryption, that's good. It's stored on the client, similar, we're basically going to store it in a cookie. It's only sent as needed. So it's a little bit more efficient than cookies, which are always sent. We don't have to hit the database as often. Tokens can include their own expiration date. And again, it's basically the encryption. So again, high level, we're going to be working with cookies and tokens inside of the cookies to create sessions to allow the server to remember who the client is. And again, we can get into JSON Web Tokens and read a little bit more about them. But you know what JSON is, JavaScript object notation. It's a JavaScript object with a key and a value separated by a colon to store our information. And it's basically encrypted, and it's basically a standard and it can be trusted because it's using encryption. When should you use JSON Web Tokens? Well, exactly what we're talking about, authorization. And so when it comes to a JSON Web Token, okay, in a compacted form, JSON Web Tokens consist of 3 parts. Okay, and you're going to see these terms used. Okay, header, a payload, and a signature. Now, your payload is your data. Header contains data in it, and a signature is what's used for encryption. Again, so the header consists of 2 parts: the type of token that it is, which is JWT, and the signing algorithm, which is SHA-256. So that's kind of some information. This is a JSON Web Token, and we're using SHA-256. So this would be, something of what the header might look like. This is an object that says, hey, this is a SHA-256 algorithm, and this is a JSON Web Token. The payload is your data. So what is the data that is, ultimately this will be our, our credentials. username, so on and so forth, and maybe like a role, like, hey, we're an admin. And the signature, it says to create the signature part, you have to take the header. So you encode the header, you encode the payload, a secret. This is all used basically to encrypt the data. So a web token, basically looks like this long string of meaningless information, but it breaks down into a header, a bunch of data, and information to encrypt that. That kind of makes sure the benefit of using this like a hash is that you make sure the data isn't tampered with, right? So I always think of like the old game of telephone that we played as a kid. And what telephone was as a kid is, in a class of 20 students, you would just tell your friend a message, and then he would tell the next person him the message, and the message would kind of start at the beginning, and it would reach the end, and everyone would share the same message. But by the time it got to the last person, the message has certainly changed, right? It's no longer the same original message. Grant, did you play that game as a kid?
Yeah, definitely.
Yeah. And so the benefit of a hashing algorithm is that mathematically it will prove that your message is unchanged. And so no one tampered with the data in between. And again, that's a security feature. Okay, so again, JSON Web Tokens for authentication tokens, right? We're going to create authentication tokens and store them in cookies to basically create this connection between client and server and authenticate the user over a duration of time. Okay, so again, this is kind of using the old module syntax. You bring in JWT. Here's our payload. Payload is just another word for data. So this is the data that we're going to basically put into a token. Okay, your secret is this is the string that will be used by the hashing algorithm to make sure the data doesn't change. So this is my super secret string, and it's obviously not a super secret string, but the idea is that it should be something that you keep as like its own password, because if you have the secret, then you can decrypt basically the data, and it's no longer secure. So that is that's a password essentially of its own. And you say, how long does the token last? And so 3 parts: payload, a secret, and an expiration. And we create the token with this sign method, passing it those 3 parts. Okay, so that's kind of the JavaScript line of code that creates a token, and then you can store that token in a cookie on the client. And then this is like, for example, when would you do this? Okay, you might create this token when a user registers or when a user logs in, right? When a user registers or when a user logs in, you want to create that token and store it on the client, right? But then let's say they go back to your website, you might want to verify that the user is still logged in, right? That the token hasn't expired, that the cookie hasn't expired, and you do that with a verify method. So there's basically a signing method, right, to create a token, and then there's a verify method to make sure that the user, is still logged in, is still authenticated, right? And this verify method would return the payload, right? So if this verify method returns true, and basically the token hasn't expired, and you provided the correct secret, right? If you provided the correct secret, then the data is returned. So if the token is valid, verify will return the decoded payload. But if it's invalid or expired, invalid meaning you didn't give it the right secret, or the expiration date has expired, it will throw an error. Okay, again, the secret right here is basically its own set of passwords. And so, you can generate a nice secure password by going to, passwordgenerator.net and saying, hey, I want a 256 string password, right? The number one thing you can do to make a secure password, the number one thing that makes a password secure is not special characters, but is absolutely its length. So you want to make a secure password, make it longer. Okay, that'll make it harder to quote unquote hack. That's the number one thing you can do. Okay, and just like before, we can store, secrets like our credentials inside of our config package, right? So here there might be an auth field that we create with a secret, an expiration, and max age. Okay, I think that's the main thing I wanted to hit. I wanted to hit on those three packages. We're not going to do anything with we're going to store our JSON web tokens in cookies. It says, but another common practice is to send them in an authorization header. We're not going to do that. So I think we can actually skip this, because this kind of gives you this Windows prompt. Obviously, we're not going to be logging into our website through a Windows prompt. So we're not actually going to be doing that. So I'm not too worried about that. Status codes, you're familiar. We've already covered status codes. But on a review, 401 is unauthorized, aka you're not logged in. So 400 category in general means there's a client-side problem. 401 specifically means you're not logged in. You're not authorized. 403 forbidden means you don't have the permissions, right? So authentication versus authorization. So this is an authentication. 403 authorization. You're not authorized here, right? You've heard that before. Unauthorized. You're not allowed. Forbidden. You're in a place you're not supposed to be. You have valid credentials, but you don't have the sufficient permissions to access the resource. So we will discuss these further in the next lesson. Okay. And we'll do this. We'll kind of get into these little code demos in the actual coding demonstration of this. Okay, just wanted to hit some of the theory. That's a good stopping point right here. And then in the next video, we'll actually write some code.